Hello everyone and welcome back to another video. So today we're going to be taking a look at the LeetCode question, longest valid parentheses. Alright, so in this question we're going to be given a string containing just the characters. So we have the open parentheses and the closed parentheses. And our goal is to find the length of the longest valid parentheses substring. So what I first want to do is go over what the question is actually asking for, since I do think it is a little bit tricky, and then we're going to go through a solution and then go over the code for it. Alright, so this question is asking us for the largest set of valid parentheses that we have. So this doesn't just mean what is the longest parentheses that we have. So for example, one thing you could think is this is the first opening parentheses and this is the last closing parentheses. So the longest parentheses set would just include all of this with a length of 3, but that is not the case, right? So everything inside of whatever we're considering for the length has to be accounted for and a valid, well-formed parentheses set. So for example, in this case, the answer would just be this set of parentheses. And the reason for that is over here we have a open parentheses, I'll just call it A, and over here we have another open parentheses called B. So in this case, first thing that needs to be accounted for is whatever is inside, right? So the next closing parentheses is going to be for B and it's not going to be for A. So this basically tells us that this set of parentheses has been fully valid and accounted for, and now we're going to return a length of 2, okay? So let's just look at one more example, a lot simpler. So over here we have open, open, closed, closed, right? So in this case, let's just call this A. We have an open parentheses, another open parentheses called B, and then we have the first closed parentheses. And the first closed parentheses is going to account for or going to be the complement for B. So that, let's just call it B dash. And then we're going to have another closed parentheses called A dash. So in this case, all of the open parentheses have been accounted for by the closed parentheses and they are done in a proper order. So in this case, the valid set would be the entire thing with a length of 4, and that's what we end up returning. So one kind of pattern that you can notice is the fact that the number of open parentheses has to be equal to the number of closed parentheses. So while this is one condition, this is not the only condition that we have, because the order of this also matters. So let's just look at one example quickly. So let's say we have open, close, and then close, open. So in this case, this condition is satisfied, right? Number of open is equal to number of closed. But in this case, so we have open, closed, so this is a valid set. But in this case, we have closed, open, which does not make sense. So this does not form a valid set of parentheses. And in this case, the only valid set we have is this over here, and we return a length of 2. So the other thing that we need to worry about is the order at which this is done. So now hopefully that you understand the question, let's try to look for a solution to this. And I just want to do this by showing you a quick example. And in this case, we have this example. So let's say we have 3 open parentheses and 3 closed parentheses. So in this case, let's call them A, and then B, and then C, okay? Now the complement, so the first closed parentheses is going to be the complement for C, right? Then this is going to be the complement, this is going to be the complement for B, and this is going to be the complement for A. So basically what I'm trying to show by doing this is that whatever is the first parentheses we see, so first we saw A, right? And this A is going to have the last closing bracket, okay? And everything else inside of it is going to follow the same pattern. So this, another way to say this is whatever comes in first, so first in is the last to go out. So first in, last out. And another way to say this, which is more popularly said, is last in, first out. So it's essentially just the opposite of it. And this actually just, the abbreviation of it is LIFO, LIFO. And if you know what this is actually what a stack does. And a stack is a data structure which follows a structure where whatever we first put in is the last thing to come out. Or in other words, whatever we put in last is the first thing to come out. And this is going to help us make sure that our parentheses follow the correct order, and we can also make sure that it follows this rule. So the data structure that we're going to be using is a stack, and now let's see how exactly we're going to use the stack to solve the question. So over here I have 3 examples, and we'll go through the 3 examples, and each time we're going to be adding a new element to our solution. So before that, let's real quickly just go over the solution for this. So over here, the valid set is going to be these 2 with a length of 2. So the valid set over here is going to be the entire thing with a length of 4, and over here it's going to be this part right over there with a length of 4 again. Okay, so now that we understand this, let's go over how we're going to use a stack. So let's first look at example 1. So first let's draw our stack. So this is how a stack is usually represented, and the reason it's done so is because just to iterate over the fact that last in, first out. Okay, so this is going to be our stack, and we're going to have another variable, and let's just call this variable result, okay, or res. So the idea of res is that each time we're going to be updating res in such a way that we have the maximum length of the valid set of parentheses. So in the beginning, it's going to be initialized to 0. All right, so what exactly are we going to do with the stack? So our main idea here is that every time we come across an open parentheses, we're going to add it to the stack. And to be more precise, we're going to be adding its index to the stack. And every time we do that, so it's going to keep stacking on. And at one point, whenever we come across a closed set of parentheses, then we're going to take off whatever is at the topmost of the stack, and we're going to pop it out, okay? And the essential idea is that when we have, so let's say we first put in A and then B, and then we come across a closed set of parentheses, that closed set refers to the topmost element, which is B, or in other words, the innermost parentheses, right? So hopefully you are understanding the intuition behind this. All right, so let's just look at one example. I think it should be a lot clearer. So in this case, the green values are obviously going to be the index values. So first, we have an open parentheses with the index of 0. So we're going to add that to our stack. We have 0. Then we have another open parentheses, so we're going to add that as well. So over here we have 1. And then we have a closed parentheses with 2. So when we have a closed parentheses, there's 2 things that are going to happen. The first is that we're going to pop out the last element. So essentially, by popping it out, what we're saying is that we found a pair or valid pair, right? So in this case, the valid pair is 1 and 2, and that's been accounted for. And simultaneously, the other thing we need to do is we need to update our result to the new valid, largest valid set we have. Now, how exactly are we going to do that? So to do that, what we're going to do is we're going to go to the current index we're on, which is currently the index 2, and we're going to subtract it with whatever is on top of our stack, okay? So in this case, we have 0. So our new result is going to be the maximum between the old result and 2 minus 0, which is nothing else but 2. So in this case, obviously 2 is greater than 0, and that is going to be our new result. Now, how exactly does that make sense, or why does that make sense? So essentially what this is telling us is once we reach the ending, and if there is something still left in the stack, that means that this thing, whatever is left in it, has not been accounted for. So everything before that index cannot be accounted for, but everything from the right of the index 0 in this case has been accounted for and is a valid set. So essentially we're going to the current index we're on and subtracting it from where the valid set last started. So in this case, it started from 0. So in other words, it's starting from 1. And we get the length by doing the current index minus this. Okay, so in this case, we got the result 2, which is what we're looking for. So now let's move on to the next example, and I'll just go through this quickly since there's one thing we need to add when we do this example. And we're going to come across a problem. So first we have 0, open parentheses, then 1, and then we come across a closed parenthesis, so we pop this out. And, oh, sorry about that. So we have result, which starts off at 0. And when we pop it out, we need to get this value. So we're at the second index, and we're going to do 2 minus 0, giving us a length of 2 over here. And in this case, that makes sense. So basically, what we're saying is we're accounting for these 2 over here. Okay, now again, we have another closed parentheses. So in this case, this is going to go out as well. And now what's going to happen is to find the current result, we're going to do 3 minus the top value over here. But there's nothing. It's going to be 3 minus none. And obviously, this is going to give us an error. So how exactly do we combat or come across this issue? So one simple fix to this is when we have something such as this, where the entire set is valid, what we're going to do is we're going to start off our stack with -1 always. So let's just see how this actually works. So let's just do the same thing again. So we have 0, then we would have 1, then we pop out 1, and the result will become 2. And then we pop out 0, and now we still have the element -1 left in our stack. So what's going to happen is our new result value, or the length, is going to be the current index, which is 3, subtracted by whatever value this is over here. And that is -1, and that is nothing else but 3 plus 1, which is equal to 4. So 4 is actually the length of this, and result in this case is now going to be 4 as well. That's what we're going to end up returning. So in simple words, what happened is when we popped out the 0, what happened is that we accounted for 3 and 0 as well, and everything in between of it. So we got that length, and the way we got that length is by having a -1, which ensures us in these cases where the entire set itself is a valid parentheses set per se, right? Okay, and now let's finally go on to the last example. So now we know our stack has to start off with -1 in it, and result starts off with 0. So again, we have another problem here. The first value over here is a closed parentheses. Now, what exactly do we do? So, okay, let's say we pop it out. So in this case, we're going to pop out -1. But now what do we do once we're over here? We can't pop anything out, right? There's nothing in our stack. So how do we actually account for this situation? So to account for this situation, what we're going to do is we're just going to add that index to it, okay? So essentially what that means is, so currently it's -1, and what is going to happen is the first time we're going to pop out -1, so -1 goes out, so let's just erase it, okay? And now we're at the index 1. So in this condition, what we're going to do is we're actually just going to add the index 1 to it. For this to make sense, another way to look at it is that we're basically kind of seeing it as everything after 1 can be part of a valid set, but anything before 1 is not part of the valid set. And that makes sense because so far this cannot be part of the valid set. So anything only after the index 1 can be part of the valid set. So at least that's how I understood it, and I think that makes a lot of sense as well. Okay, so in this case, we're currently at 1, and now we're going to move on to the index 2. So at index 2, we have an open parenthesis, so we add that. And then we have a closed parenthesis, so we pop it out. And then we need to find the new value, which is going to be 3 minus whatever is over here, which is 1. So 3 minus 1 is equal to 2. So the length is equal to 2. And that's going to be our new result value over here. All right, so now we're at the 4th index. So we add that since it's an open parentheses. And then the 5th index, we get rid of it. And we find the new value, which is going to be 5 minus what's over here, 1, which is equal to 4. And this gives us a length of 4, which accounts for all of this. And that's going to be our new result since 4 is greater than 2. All right, and finally we have 6, which is an open parentheses. We just add it on, and that's it. So we reach the ending, and there's nothing for us to do. So hopefully you did understand, and at each condition we added a new thing that we had to look for. So what we ended up doing here is we're starting off with -1, and what we did over here is when we have a closed parentheses, for example, in the beginning or when the stack is out or empty, then in that case, we're going to add its index to it, okay? Actually, before going to the code, let's go over the time and space complexity. So let's first go over the time complexity. And no matter what the condition is, we would have to iterate through the entire input that we have. So our time is going to be big O of n, where n is the length of the input. Now, what about our space complexity? Now, in a worst case scenario, we could just have a ton of open brackets. And in this case, we would have to store all n of these into our stack. So in the worst case, we're going to have a space complexity of big O of n. So now let's take a look at the Python solution first. All right, so we're first going to define our stack, and we're going to use a list to do that. And remember, the first value is going to be -1. We're also going to have our result, which is going to start off at 0. So now we need to have a for loop, and we're going to go over the indices of our input. So for I in range of length of s. All right, perfect. So the first thing we want to do is we want to check whether we have a open or a closed bracket. So if si is equal to a open bracket, so in this condition, what we need to do is we just need to add that index to our stack. So stack.append, we're going to append I. But if this is not the case, then that means that we have a closed parentheses. So the first thing that we want to do no matter what is we need to pop it out, okay? So we're popping it out, and this pops out whatever is on top, like the last index. Now the next thing that we need to do is we have a condition, which is there might be a case where our stack is empty. And to check for that, we can just do if length of stack is equal to 0. So if this condition over here is true, then in that case, we're going to add that index to our stack as well. Now, if this condition is not true, then that means that there's something still in our stack, and we want to calculate that value. And the way we calculate it is we go to the current index, and we're going to go to the top of our stack. And a way we can do that is we just go to the last index, which is nothing else but -1. So this is going to be one of the values, and this is what res is going to be equal to. But specifically, the previous result could be higher. So we're going to take the maximum between the previous result and whatever current result that we have right now, okay? So this is going to be our solution, and at the very ending, all we need to do is outside of the for loop, we're going to return our result, and let's submit this. So as you can see, it is accepted, and let's see the same thing in Java now. So the first thing we want to do is we want to define our stack, and it's going to be holding an integer. So let's just call it stack, and we want to initialize a new empty stack. So the first thing we want to do to the stack is, like we went over earlier, is we're going to append the first value to it. It's going to be -1. So we're going to do stack.push -1. All right, so the next thing is we want a variable which we're going to return. This is going to have the length of the longest valid parentheses. So let's just call it result, and it's going to start off with a value of 0. Okay, so now we're going to go inside of a for loop, and let's do for int I is equal to 0, and we're going to keep going as long as it's less than s.length, and each time we're going to increment it by 1. Okay, so the condition here is we want to check whether we have a open or a closed parentheses. And to get that, we're going to go to s.character at, and we're going to go to index I, and we're going to check to see if this is equal to a, let's say, a open parentheses in this case. So if it is a open parentheses, then in that case, it's pretty simple. We're going to go to our stack, and we're going to push whatever index we're currently on. So stack.push I. Perfect. But if this is not the case, then that means we obviously have a closed parentheses. In this case, the first thing we need to do is we want to pop out the topmost value. So we do that by just doing stack.pop. And over here, we have two conditions. So one of the conditions is that our stack could be empty. So if our stack is empty, then in that case, that means we're going to add whatever index we're currently on to our stack. So we're going to do that by doing stack.push, and we're going to be adding the index I. But if this is not the case, then that means our stack is not empty, and we can find a value for the result. So we're going to do that by doing I minus whatever is on top of the stack. So how exactly do we get that value? And we can do that by just doing stack.p. And that is going to, p. So that is going to give us the topmost value of the stack. So this is going to be the value of our result, but the previous result could be greater than this. So we're going to be taking the maximum, so it will be math.max between the previous result and whatever result we just found currently. So that's all we have to do. And finally, at the very ending, we need to return our result. So outside of the for loop over here, we're going to return res. Okay, perfect. So let's submit this. And as you can see, our submission was accepted. So thanks a lot for watching. Hopefully this video did help you. And don't forget to like and subscribe. Thank you.